Engineering Mathematics, Linear Algebra Part 3. So these are some useful instructions. You can change the video quality by clicking at the bottom right corner of the YouTube video player. You can watch at least in 360p for better clarity. If the video is found slow, you can change the video speed by changing at the speed at the bottom right corner of the YouTube video player. In the same way, you can reduce the speed also. Please don't post unwanted comments and all. These videos are prepared just for sharing the knowledge. If the video is found useful, you can subscribe our channel and you can share the video to your friends in various platforms. You can ask questions and request videos on required topics. We will try our best to meet your requirements. So now we are going to the concepts. So this is the third lecture from linear algebra. In this lecture we will be discussing the concepts of rank of the matrix and solution of linear equations. So what is meant by rank of a matrix? Rank of a matrix is number of linearly independent rows in a matrix. So we have a matrix A. So there are number of rows. If it is having m rows, then it will be a m by matrix, that is m rows and n column, it's a m by n matrix. So rank of the matrix is number of linearly independent rows in a matrix. There will be different rows. If the rows are linearly independent, then how many such linearly independent rows are there? It is the rank of the matrix. Or it is also the order of the highest non-singular submatrix. So we have a matrix, so we can take a non-singular submatrix from that if it is the order of the non-singular submatrix. So it is an easier way to find the rank of the matrix when a matrix is given. We will explain this concept in coming examples. Then if A equal to 0, that is A is a null matrix, then the rank of the matrix is 0. In the similar way, for an identity matrix of order n, the rank is n itself. The rank of a 2 into matrix, let it be called A, we can compute in a easy way. So if rank of A equal to 2, that is it's just 2 by 2 matrix, and if rank of A equal to 2 itself, its determinant, that is AD minus BC, we discussed this one in the last lecture, if it is not equal to 0. Okay, since both the column vectors are independent in this case, that is AD minus BC, if AD minus BC, that is the determinant of the matrix, is not equal to 0, then rank of A equal to, that is rank of the 2 by 2 matrix is 2 itself. If rank of A equal to 1, if determinant equal to 0, and rank of A equal to 0 if A equal to 0. So for a 2 by 2 matrix there are three possibilities, that is rank can be 0 if matrix itself is null matrix, if rank of A equal to 1 if determinant equal to 0, if rank of A equal to 2 if determinant not equal to 0. So there is another method for finding the rank of the matrix. It is called a row echelon form. That is, we will convert the matrix in a row echelon form. It is the upper triangular form of a matrix, which means that the lower part will be 0 below the diagonal. So here this is the standard form, and here is an example on the left side. So in the standard form, the blue part, the triangle and rectangle shown are zeros. So there will be only the upper part, upper triangular part, that will be only non-zero elements. So here is an example for a row echelon form. So how we will convert a matrix into row echelon form? So we will be given a matrix, so we will do row operations. We will explain the row operations in the next slide, and we will do row operation and convert the matrix into this form. So after converting to this form, what we have to do, we have to count how many non-zero rows are there. So in this case, here the first row is 3 2 1, it's a non-zero row. Second is 0 minus 1 by 3 1 by 3, it's a non-zero row. Why non-zero row? Because there is non-zero element in that row. But the third row, it is 0 0 0, all the elements are 0, it's a 0 row. So there are only 2 non-zero rows in the matrix, so the rank of the matrix is 2 in this case. So what we have to do, first we have to convert the matrix into row echelon form, then count the number of non-zero rows. Okay, so now we will solve an example. So we have a matrix, that is a 3 row and 4 column matrix, that 3 by 4 matrix, and you have to remember that the rank of the matrix is not a property of a square matrix. For every matrix, rank exists. Okay, the matrix A is given as 3 0 2 2 minus 6 42 24 54 21 minus 21 0 minus 15. The number of linearly independent rows, which means that there are 3 rows. So the maximum possible rank is 3 because there is only number of 3 rows. So maximum number of possible independent rows is 3. So the maximum rank possible is 3. So it is not a null matrix. So rank cannot be 0. So minimum possible rank is 1. Okay. So now we have to find out how many linearly independent rows are there. We will do it by converting it into that row echelon form. So we will do the row operations. What is mean by row operations? We will add the one row with another row, or we will add one row plus a scalar multiplied by the other row. So what I have to do, I want to do the first row I will keep the same, and I want to keep this minus 6 0 and 42 I will keep it 21 0 and minus 21 0. Okay. So for that I want to convert this minus 6 into 0. I want to convert this minus 6 into 0. So for what will I will do? What I can do, the second, that is minus 6 plus 6 is equal to 0. So I want to convert, that is I will do R2 row 2 plus 2 into row 1, which means that second row, all the terms in the second row plus 2 into 2 times the first row. So the first term will become minus 6 plus 2 into 3, that is equal to minus 6 plus 6, that is equal to 0. The second one become 42 plus 2 into 0, that is 42 itself. Third is 24 plus 2 into 2, that is equal to 24 plus 4, that is 28. Next is 54 plus 2 into 2, that is 54 plus 4, that is 58. For third row I want to convert this 21 into 0. So converting this 21 into 0, what I can do, row 3 minus 21 minus 3 times the 7 times the row 1, that is 7 into row 1. So 21 minus 7 times 3, that is 21, that is equal to 0. So I will get 0 here, and minus 21 minus 7 into 0, that is equal to minus 21 itself. 0 minus 7 into 2, that's equal to 0 minus 14, that's minus 14. Then minus 15 minus 7 into 2, that is equal to minus 15 minus 7 into 2, 14, that is equal to minus 29. So I got this form. Now it is not the row echelon form. I have to convert this minus 21 into 0. How will I convert the minus 21 into 0? This here is 42 on the second row. So I can multiply the row 3 with the 2, so that I will minus 42, then add with the second row. Okay. Or I can do the row 3 plus half of the row 2. So I am doing that 0, row 3 is 0, 0 plus half of the 0, that is 0 itself, that is we will get 0. Then minus 21 plus half of the 42, that is equal to 21, that is we will get 0. Then minus 14 plus 28 by 2, that's equal to 0. Minus 29 plus 58 by 2, that's equal to 0. So now I got the row echelon form. So now I just want to count the number of linearly independent rows. You can count it. The first row is non-zero row, so it is 1. Then next is non-zero row, that 2. Then third row is fully 0. So number of non-zero rows is 2. So the rank of the matrix is 2. I hope you got the concept. You can solve as many problems as possible for understanding this. Okay, the last matrix in row echelon form has only 2 non-zero rows, hence the rank of the matrix is 2. Then now we are going to discuss the solution of linear systems. So there are two types of system, homogeneous and non-homogeneous system. So first we will discuss non-homogeneous system. Consider the non-homogeneous system will look like the form Ax is equal to B. That's A is a matrix, X is the matrix of unknowns, and B is the right side of the matrix. So in the coefficient matrix A and AB, we will write A matrix and B matrix together, then it is called augmented matrix. So two possibilities of existing solutions. So Axx equal to B is inconsistent, which means that there is no possibility of existing solution, that is no solution exists if rank of A not equal to less than rank of AB, or rank of A not equal to rank of AB. Then Axx equal to b, Ax equal to b has a unique solution if rank of A equal to rank of AB equal to number of unknowns, and Ax equal to b has infinitely many solution if rank of A equal to rank of AB and it is less than number of unknowns. So I am explaining with the concept. Here is a matrix 3 2 1 0 minus 1 by 3 with 1 by 3 0 0. Let us call it as A matrix, and the B matrix is 3 minus 2 12. So the augmented matrix, we will write the A matrix and B matrix together by separating with the dotted line. That is called augmented matrix, which is written on the right side. When solving the problems, you will understand this concept. So in linear equations, the unknowns appear raised to the power 1, which means that x, y, not x square, x cube, etc. It will be the power of 1 only. So the variables in the equations are ordered as x1, x2, etc., x3, etc., or normally we will write x, y, z, and so on. So linear equation can be written in the form of matrix. So we can do the matrix multiplication and we will get the linear equations. By using the inverse concept of the matrix, we can find the solution also. So non-homogeneous linear system of matrix, which means that in the previous case, that is we are at Ax equal to b, that is a non-homogeneous system. That is, it will look like this: a11 x1 plus a12 x2 plus etc. a1n xn equal to b1. This form of linear equations will be there, so we can convert it into matrix form. So on the left side you can cite a11 a12 etc. a1n, that is the A matrix, that is the coefficient matrix of x. Then next is a column matrix of unknowns x1 x2 etc. xn, and b is the right side, that is b1 b2 bn, the A matrix, x matrix, and b. I hope you got that. Ax equal to b form. So how to solve the non-homogeneous linear equation, we will be introducing that. So we can use our 2 into matrix to express two simultaneous equations. First I will explain it with the 2 by 2 matrix. So after getting the linear equation, we have to put it in the correct format, in the matrix format. For variables x and y, in the format should be ax plus by equal to m and cx plus dy equal to n. These are the two linear equation to solve, where x and y are the variables and a, b, c, d are the coefficients, and m and n on the right side, which will be constant. So we will solve with an example. So here is a question: Peter and Jane together spend 240 and Peter spent 3 times as much as Jane. Then how much Peter spent and how much Jane spent? Okay, so we have to convert it into linear equation form, then a matrix form, then we have to solve it. So let P is what Peter spends and J is what Jane spends. That is, we know that altogether they spent 240. That is why P plus J equal to 240. Okay, together they spent 240. When we are comparing this equation with the P plus J equal to 240 with the first equation Ax plus By equal to m, where A equal to 1, the coefficient of P, and B is equal to 1, the coefficient of Y, and m equal to 240, where P and J are the variables instead of x and y. The second equation that we have to form, to solve two unknowns, we need at least 2 equations. Okay, to solve 3 equations, 3 unknowns, we need at least 3 equations. So here there are 2 unknowns, so we need 2 equations. The another condition given that Peter spends 3 times as much as Jane, so P is equal to 3J. Peter spends 3 times Jane, but it is not a correct format because we want to get it in the cx plus dy equal to n format. So we can take the 3j on the left side, so we will get p minus 3j equal to 0. That is the right format, and the coefficient of p, that is 1, and coefficient of j is minus 3, and the right side value is 0. So now we got the 2 linear equations. So next, if the form is ax plus by equal to m and cx plus dy equal to n, we have to convert it into the matrix form. That is, on the left side coefficient matrix, that is a, b, c, d, and right side column matrix x, y unknowns, then right side matrix m by n column matrix. Okay, then what we will do, we will multiply both sides by the inverse of the coefficient matrix. So we have to find the inverse of the ABCD, and we will multiply both sides. Then on the left side, when multiplying A inverse into A, it will become identity matrix. So only xy will be existing, equal to A inverse into m by n. So for a 2 into matrix, we know how to find the inverse of the matrix. If you didn't know how to find the inverse of 2 by 2 matrix, you can watch our lecture 2, because we deeply conceptually explain how we are finding the determinant of inverse of the 2 into matrix. So this is a simple format. A B C D all inverse is equal to 1 by AD minus BC into DA minus B and minus C. Okay, that is D minus B minus C A. So if we know the if we can find out the inverse of the matrix, just multiply it with the m by n matrix, then we will get the solutions. So we will be solving the Peter and Jane problem by using this concept. So this is a format. So we know that x plus y equal to 240 and x minus 3y equal to 0. I converted P as x and Jane as y. Don't confuse with that. So it becomes the matrix 1 1 1 minus 3 x1 x2 equal to 240 0. Okay, then we have to find out the inverse of 1 1 1 minus 3. So for identification, I just explained this one also. On the left side, we have the coefficient matrix x1 x2 unknowns, and 240 and 0 are the constants from the right hand side. Then we will find Ax equal to B format, and we will find the inverse of 1 1 1 minus 3. Find the inverse. So by using the method that we explained in the last slide, this is the inverse of the matrix. Just multiply it with the 240 0, then we will get the values of x and y. So we are multiplying it, so we will get 180 and 60. If you don't know how to find the inverse or how to multiply two matrices, please watch lecture number 2, that is part 2, linear algebra. Okay, now we got the solution x1 x2 equal to 180 60. So according to equality of the matrices, x1 equal to 180 and x2 equal to 60, which means that Peter spent 180 and Jane spent 60. So it is satisfying the both criteria, that is altogether spent 240, the sum is 240, and Peter spent 3 times the Jane, that is 3 into 60 is 180. So this is a solution. Okay, I hope you got the concept. You can solve problem to practice this concept. So the answer is P is equal to 180 and J is equal to 60. So now we are going to the 3 variables problem. So here is the question: 4x plus y plus 2z equal to 4, 5x plus 2y plus z equal to 4, and x plus 3z is equal to 3. So in the last equation, it is x plus 3z is equal to 3. So we have to convert x plus 0 y plus 3z equal to 3. Okay, the coefficient of y is 0. So now we will convert the matrix. This is the coefficient matrix 4 1 2 5 2 1 and 1 0 3. And steps: format the simultaneous equations in the variable x y z, then rewrite in the matrix form. So we wrote the coefficient matrix, find the inverse of the 3 into 3 matrix A, then multiply it with the right side matrix, solve the equations. Okay, so how to find the inverse of the matrix? In the last lecture, we explained the concept of finding the inverse of the matrix by computing the cofactor of the matrix and adjoint. Last lecture I told that we will explaining the finding the inverse method with the example in coming lecture. So here is an example how to find the minor and how to find the cofactor matrix and adjoint matrix. So first we want to find the inverse of the matrix. For finding the inverse of the matrix, we need cofactor matrix, and the transpose of the cofactor matrix is adjoint of the matrix. So inverse of the matrix is adj A by determinant A. So here is our matrix on the right side 4 1 2 5 2 1 1 0 3, and here is the cofactor matrix. Now I am explaining how I got the elements in the cofactor matrix. So the element in the cofactor matrix, that is 6, which is rounded with the red letter. How I got it? For the position of 4, that is A11, I got 6. So what I will do, I will remove the row and column which is marked in the red colored mark. I will remove that and find the determinant. 2 into 3, that is M11, I written as minor, that is 2 into 3 minus 1 into 0, that is 6 minus 0, that is 6. Please check the location is 1 1. So minus 1 raised to 1 plus 1, that is minus 1 square into 6, that is plus 6 we will get. So the cofactor element is 6. Okay, so the second element place for 1 one for the position of minus 14. So the first row and the second column I removed. The remaining minor is 5 3 1 1. So we will find the determinant, that's equal to 3 into 5 15 minus 1, that is equal to 14, and the location is 1 2. So minus 1 raised to 1 plus 2, that is minus 1 raised to 3, that's equal to minus 1. So minus 1 into 14, that is minus 14. So the cofactor element is minus 14. In the same way we can find the minus 2 in the cofactor element for the position of 2, that is A13, removing the row and column belonging to that. So find the minor 5 2 1 0, determinant that 5 into 0 0 minus 1 into 2, that's equal to minus 2 for the position 1 3. So minus 1 raised to 1 plus 3, that is equal to minus 1 raised to 4 into minus 2, that's equal to 1 into minus 2, that's minus 2. So I got the minus 2 in the cofactor matrix. So in the similar way, by removing the rows and columns, we can find the elements in the cofactor matrix. So here is the minus for minus 3, and here is for that 10, how I got the 10, then here how I got the 1 here. The similar way you can check it, you can try your own and you can check it, cross check it with. So in this way we will get the cofactor matrix. So now we want to find the adjoint of the matrix. Adjoint matrix is just the transpose of the cofactor matrix, that is we are interchanging the rows and column. The first column will become first row. So 6 minus 3 minus 3 is the first column here, so in the adjoint it will become the first row. In the similar way we will get the adjoint of the matrix. So now we got the adjoint of the matrix. Okay, then we will find the determinant of the matrix. So adjoint of the matrix divided by determinant of the matrix is the inverse. So for that matrix we got the determinant as 6. So adj A into 1 by 6, 1 by times the determinant, we will get the A inverse, and multiplying that A inverse with the right side matrix, that is B 4 4 3, that is B, we will get the x equal to 1 by 2, y equal to 1 by 3, and z is equal to 5 by 6. You can try your own and comment your observation. If you are having any query, we will explaining with another separate video for this. You can check your own. Okay, so in this way you can find the solution x y z. So we will get the value of x equal to 1 by 2, y equal to 1 by 3, and z is equal to 5 by 6. There are easier method for finding the inverse of the matrix. We will explaining it with a separate video in coming lectures. For that, subscribe our channel and wait for that. So now we are going to the homogeneous linear systems. For homogeneous linear system means Ax equal to 0 or 0 form, that's Ax equal to 0, that is the right side matrix, that B equal to a null matrix. So what is the peculiarity of a homogeneous linear system? The homogeneous linear system is always consistent, which means that there is always a solution for that. That is x equal to x1 equal to x2 equal to x3 equal to etc equal to 0. So there is always one solution for that, that's equal to, for all the coefficient, all the elements are 0. But for existing in another solution, that is for the solution which is x1 equal to x2 equal to 0 is called a trivial solution, and for existing a non-trivial solution, determinant of A should be equal to 0, and there will be infinite number of solutions in that case. Okay, that is a homogeneous system of equation Ax equal to 0 has non-trivial solution if and only if equation has at least one free variable, which means that the determinant should be equal to 0. Okay, here is an example for homogeneous linear system. You can see that there will be a coefficient matrix and variable matrix, and but on the right side the B matrix will be a null matrix. And every homogeneous linear system is always consistent, you should remember that. So now we will solve a homogeneous system of equations. So here is the question: 3x1 plus 5x2 minus 4x3 equal to 0, minus 3x1 minus 2x2 plus 4x3 equal to 0, 6x1 plus x2 minus 8x3 equal to 0. So we can find the by reducing the augmented matrix into echelon form. So we know what is echelon form. So this is a matrix, so we will convert into echelon form like this. This is the echelon form we will get. Okay, so how we are converting it into echelon form, I will explain with again. I want to convert this minus 3, that is second row first element, that's minus 3 to 0. So I can add the first row and second row so that it will become minus 0. So I am adding first row and second, so I will get 3 plus minus 3 0, and 5 plus minus 2 3, minus 4 plus 4, that is 0, 0 plus 0, that is 0. Again I want to convert this 6 into 0, that is third row first element, that's equal to 0. So how I can convert that matrix into minus 2 times the first row, that row third row minus 2 times the first row. So I will get 6 minus 2 into 3, that is equal to 0, that's equal to 1 minus 10, that's equal to minus 10, minus 8 minus 8, that's equal to 0, and the last it is 0 0. So after converting the row echelon form, I will got this matrix. So this is the echelon form of the matrix. So from this you can understand that rank of A, that is of rank of A is equal to 2, because there is only 2 non-zero rows, and the rank of AB is also equal to 2. If rank of A equal to rank of AB, if it is always consistent, and it is less than number of unknowns. Here the number of unknowns is 3, so it is less than number of unknowns, that is only 2. Rank is only 2, it is less than the number of unknown, hence it will have infinite number of solution. So we can reduce that. So here x3 is a free variable because it has only 2 solution. Whatever the value of x3, what is mean by x3 is a free variable, whatever be the value of x3, there will be always a solution for that. So how we can find out? I will reduce it into a good form. So here is the echelon form. So I can write it as x1 minus 0. When I am multiplying with the x1, x2, x3, I will get as x1 minus 4 by 3 into x3 equal to 0, x2 equal to 0, and 0 equal to 0. So x2 is always 0. And next condition is x1 is equal to 4 by 3 x3, or x1 minus 4 by 3 x3 equal to 0. Whatever the value of x3, we can find the x1 value. So for that x1 value, and x2 equal to always 0, and x3 equal to, we choose on the value. So for that the solution, there will be always solution, there will be infinite number of solution for this. Okay, we can write it in this form also. X3 multiplied by 4 by 3 0 v, that is x3 into v. So v is 4 by 3 0 1. So there is another, that is x3 free. This is again showing that is how it is becoming x3 free. I hope you understand what is mean by x3 free. X3 free means what it is, the solution is independent of, the equations are independent of x3, which means that whatever the value of x3, there will be always existing a solution. You can choose any value. You can take x3 as 0, you can take x3 as 10, you can take x3 as minus 10, because the value of x1 will change according to that. So it is an x3 free. I hope you understand the concept. We will be solving more problems in coming lectures for understanding all these concepts, and there are easier method for finding the rank of the matrix, inverse of the matrix and all, and there are some tips for finding the inverse of the matrix in objective type questions also. So for those things we will be explaining coming lectures, and we will be explaining the eigenvalue, eigenvectors concepts in coming lectures. So stay tuned. You can subscribe our channel, and you can share our videos also. Thank you for watching. Thank you. You can request the videos also.